Hello everybody. So here's the problem that I presented to you in class. A rocket was fired at a 30-degree angle to the horizontal at an initial velocity of 2,500 meters per second. We want to determine our maximum height reached and the range that this rocket travels. So first thing, this problem is going to involve SOHCAHTOA. So first off, why don't we start by drawing the picture. So we want to include a picture, draw, just to figure out, the x and y components of our velocity. So first of all, here's our diagram, and we have an initial velocity of 2,500 meters per second. This is our 30-degree angle, because it tells us it's from the horizontal. So we need to solve for our x components and for our y component of this velocity. So that's our first step, to use SOHCAHTOA. So let's solve for the x first. So if we wanted to make our triangle, all right, so there's our right angle. Here's our 30 degrees. So we have an adjacent and a hypotenuse. So to solve for the x, we're going to use cosine. So cosine of 30 equals our x over 2,500. So to solve for our x, we're going to take our cosine of 30 and take it times 2,500. So we get, in the x component, the x direction, it's going 2,165 meters per second. So now in the y direction, we can use the sine of 30 degrees is equal to y over 2,500. So again, we're going to solve for y, but this time we're going to use the sine function. So the sine of 30, and take that times 2,500. So for our y component, we know it's going 1,050 meters per second in the y direction. So these two components are going to be ones that we have to sort of think about what's happening to them. So thinking through the problem, all right, which one of our velocities is going to stay constant and which one of our velocities is going to change? So that's the first question to ask yourself. Hopefully, you found that the x direction is going to remain constant. This is our horizontal one. There's nothing opposing it. We're not talking about air resistance. We're neglecting air resistance. So in this case, this one is constant. Y is changing. What is causing your y to change? Notice the direction that it's going. What is the only thing opposing that motion? So this one is changing because of gravity. So in this case, gravity is the thing that's affecting our y variable. So now we kind of have the ideas how to solve this problem. So we want to find our maximum height. Why don't we start there? We'll find our max height. So if I were to continue thinking about this motion, it's going to go up, curve, come back down. So what we want to determine is how high up in the air, so in this case, our delta x, if we think about it in the y direction, we want to find that first. So we know that our y velocity is changing, so we need to use an equation that deals with gravity. So, things that we've done before. So to help us find that height, we know our initial velocity of our rocket is our 2,500 meters per second. We know our acceleration, at least going up, is 9.8 meters per second. We know at the top of this motion, if you think about up there at the top, our final velocity at the top of our motion is going to be 0. So why don't we first solve for how long that object is going to be in the air? Because we can actually use this time to also help us solve for our range as well. So it would be a good idea to get the time first. So first of all, an equation that we can use, so look at your list of equations, and we want to find one that has those four components in it. So the equation that we want to use is we have our final velocity minus our initial velocity all over time is equal to acceleration. If we rearrange this equation, we get our final velocity minus our initial, and we divide the whole thing by our gravity of 9.8. So this will give us the time. So take your 2500 and divide by 9.8. Of 255 seconds. So this time that we just came up with, we said it's the time that it takes it to go from 2500 all the way up to a final velocity of 0. So does this time represent half the motion or the whole motion? Hopefully you said half the motion. So what we want to do to figure out sort of our total time, because we'll need that total time later, we're going to take our 255 and multiply it by 2. That way we get a time that is now our total time that this thing is in the air. All right, so how does that help us? So we have not only a total time that this is in the air, but we also now have the half time that it's in the air. Notice we're still trying to find our maximum height and our range. So that didn't get us there, but it did lead us along the right track. So, next step. Why don't we find the range? Let's see how far this thing goes. So, using our model up here, our range is going to start here. It's going to travel straight horizontal across, and it's going to end right here. So we need to use a velocity that is only going in this direction. So we're going to use our x velocity we calculated here. Knowing that it's constant, we have equations where our velocity is constant. So to help us solve for the range, so that's our next step, solving for the range. We have an equation where if we take velocity times time, that gives us a distance. In this case, this is only when velocity is constant. But the good thing is our x direction, there's nothing opposing it. There's no air resistance. Gravity doesn't affect in the x direction. So we can essentially take our 2165 meters per second times the total time that we're in the air, so 510 seconds, and we can come up with a range that this thing will travel. So take your 2165 times 510. Yes, it comes out to be a very large number. All right, so there's our range. So I'll put my little commas in here. All right, so that's our range that this object is going to travel. That's quite a long distance. But remember, it is going really fast, 2,500 meters per second. So it should be quite a large distance that it should be traveling. Next thing we want to determine is the height. So we want the maximum height again. Alrighty, in this case, our maximum height is going to go, again, in this direction up here. So we want to find out the height of this thing. So we have an equation. Height delta x equals 1/2 at squared plus v initial t. So this will help us to solve for that height. In this case, this delta x, we are referring to it as our height. So when we're plugging in our variables into our equation, that's what we have to think about that delta x as our height. 1/2 times our A. Oops. And in this case, our A is negative because we're going upwards. Our time. So now we got to look at, we have two different times. We have a time of 255 seconds to reach the peak, and we have a total time of 510 seconds to go up and come back down. Which one of these two times should we plug into our equation to give us this maximum height right here? Hopefully you picked the 255 because we want to know how long it takes it to get to that peak. Oops. And I just messed up there. So our initial velocity, we're in the y direction. So our y direction velocity is the one we want to use. That's our 1250. Because in this case, we're going straight up and down. So we want to know, this initial velocity going straight up. We want to know how high does that initial velocity take our object up into the air. So we want to use the 1250 number for our velocity initial. You can think about this as velocity initial even in the y direction. Alrighty, so now it's just a matter of chugging away with some numbers. So we're going to take our 4.9 times 255 squared. So we get a rather large number, but you should because the fact that we are dealing with large numbers now. I'm going to write down the whole number. That way I round at the end. I don't want to round during the multiplication and at the end because then you've rounded multiple times and you're more likely to be further from the answer. Okay, so here's my two numbers I want to add up. Oh, and that's a negative. I already lost that. So we want to subtract our two numbers. So 318,622.5 and 318,750. So this thing reaches a maximum height of 127.5 meters. All right, so there are our two problems. So what I have you guys do next after this problem is I would like you to look at and attempt, the worksheet on Edline. So it's going through these same similar kinds of problems. It's just I want to see how do you do so that we can come in tomorrow with some questions about how, why, what happened in this case.